Alright, now that we've talked about how to use radar during the pre-convective stage, let's move on to convective initiation. Knowing where storms are initiating is critical in how you adjust your target and navigational strategies on a chase day. Again, other tools can help with this, such as satellite and visual reconnaissance, but often radar can provide the first clue that storms are initiating. The easiest thing to look for is what we call blips on reflectivity. These are small spots of slightly enhanced reflectivity that appear seemingly out of nowhere and are the first sign that nascent updrafts are producing precipitation. Blips will often go on to become robust storms, but in certain situations they may fail to intensify and even fizzle out before new blips take off. This means that either the cap is still a bit too strong to support updraft maturation, choking off the young storms before they can intensify, or the background forcing is still too weak. In other words, the atmosphere has destabilized enough to support storm initiation, but large-scale forcing for ascent is too weak to support the maintenance of those storms. A working knowledge of how the environment is evolving is key to understanding why storm maturation attempts are failing. One radar product that's useful in monitoring updraft intensity during and after initiation is the EchoTops product, which shows the maximum height of precipitation echoes detected by the radar that exceed 18 dBz between 5,000 and 70,000 feet above radar level.
Join the Storm Chaser Coaching Discord server and get instant access to a rapidly growing storm chasing community. Once you've joined, you'll be able to chat with our coaches, get your questions answered during weekly live office hours, and discuss strategy in the forecasting and storm chasing forum. You can join the Storm Chaser Coaching Discord server right now via the link in the description.
A sister product to EchoTops is Enhanced EchoTops, which helps smooth out irregularities that can sometimes appear in EchoTops output and identifies areas where the radar could not compute a cloud top height. However, the crux of what each product represents is the same. In essence, they estimate the height corresponding to the top of an area of precipitation, and they can be a decent proxy for how tall developing or ongoing thunderstorms are. For example, the value at the center of the bullseye in this enhanced EchoTops image is 62,000 feet, which means that the radar found the highest level at which there were precipitation echoes greater than 18 dBz to be 62,000 feet above radar level. The greater the EchoTops value is at a given point, the taller and stronger the updraft or storm is. Prior to the point at which precipitation reaches the surface, EchoTops can help you identify which updrafts are strongest and may turn into bona fide storms. In a typical severe weather setup, you may see EchoTops readings of 30 to 40,000 plus feet before precipitation occurs at the surface with a given storm, so this can be a good sign that storms are initiating. Of course, storm height depends on the vertical configuration of the instability profile, so this is not always the case, but in a good chunk of severe weather setups, this works fairly well. After initiation, the EchoTops product can tell you which storms in a batch of young storms are the most robust and may hold the greatest severe weather potential in the near term. Now, just one note about the EchoTops products. Never use EchoTops to analyze updrafts that are close to the radar site you're using. In these scenarios, the highest elevation angle that the radar is scanning may not come close to the actual top of the region of precipitation, which yields vastly underestimated or missing EchoTops data. Instead, select a radar that can still effectively sample the storms but is farther away. For example, even though these storms are near the Oklahoma City radar site, you'd want to use a site like Tulsa or Frederick to properly analyze EchoTops.
Remember to check out those links in the description below, and then watch another video.